example is going to be to describe the vertical traces of, and I'll give you guys a graph, traces of, let's say f of x comma y, that's an x, is equal to x times sine y. Okay? Alright, so that's our problem. We're going to describe the vertical traces. So that means we're going to set x equal to a constant, describe that, and then separately set y equal to a constant and then describe that. Okay? So let's do the x one first. So we're going to freeze x at a. Okay, so a is a constant. So what does this give us? That says that our, so first of all, this thing that they gave us, this looks like only a two-variable function, right? But it's actually in the form x, y, f of x comma y. They just gave us this third component, our z1. They kind of just assume that we already know that x and y are there. Okay. So anyways, so if that's what we had normally, so we had x, y, f of x, y, and now we're freezing x at a, so we're going to plug in an a wherever we see an x. Our vertical trace, the formula for that is going to look like a, comma, y, comma, f of a, y. Okay, but now we can go a step further given what we see in the box, right? That's what they gave us for our f of x, y. So now if we plug in an a for the x spot and a y for the y spot, what we're going to get is a, comma, y, comma, now we don't have x times sine y, we have an a times sine y. Okay? So, what does this mean? That means that when our x is equal to a, when x is a constant at a, and y is just being itself, and it's just it's a variable still, then we get that our z coordinate, z, is equal to a, which is a constant, times sine of y, which is the variable. So this gives us basically a sine curve, right? We have like some number in front, like a 2 or 3 or whatever a might be. But anyway, so this is a sine curve. Sine curve in what plane? So let's start graphing it and we'll see how this turns out. So if we have our x, our y, and our z, okay, so let's say we set our x equal to some a, right? So this was a plane, a vertical plane, parallel to the YZ plane. Okay, so some plane like that, it's facing directly at us. Okay, it's kind of like a wall. We're facing a wall, and anyways, so this is like a sine curve. Okay, so this is gonna look like, I'll just draw a little bit of it, something like that, and it'll keep going around and around. So anyways, so this is a sine curve that is existent in a plane, x equals a. This is the x equals a is like the square that I drew, or the rectangle, the wall here, that's the plane. And then our sine curve, this is given by this formula in here. This is a, comma, y, comma, a times sine y. That's that curve right there. Okay? And it keeps going in either direction. Yeah, I just drew a little bit because I don't have time to draw everything to infinity. So anyways, but that's what that one looks like. And now let's freeze our y variable. So if we start off with, again, I'll say x, y, and then f of xy, where f of xy was given by x times sine y. Okay, so now we're going to freeze our y variable. So y, and we'll set it equal to b, which is a constant again. Okay, so this one, what will this turn out to be? This is going to be an x, comma b, comma f of xb. Okay, so now we need to plug in b for the y spot and an x for the x spot for our f of xy. So this is going to turn out to be x, comma b, comma x times sine b. So what does this third component tell us now? Our z, which is the third component, right, our height, is equal to x times sine b. So here you might be thinking, well, that's another sine graph, right? No, not exactly, because sine b, because b is a constant, that means we have like sine of, let's say pi, just to make it easier or something. Then we get 0. But it's sine of some number, some exact number. So that means that this thing here, that is a constant. Okay, so this is a constant, and x is still the variable. So that means that we have a constant times x. So that's going to be actually the equation of a line. So equation of a line, and this specifically is going to have a slope of sine b with slope equal to sine of b, whatever b might equal. Okay, so this is going to be a line. All right, so let's graph this one. So we're going to see, so here's our x, there's our y, and here's our z. So here, for this one, we froze our y variable at some constant b. Okay, so I'll call that b, and I'll draw our plane here. So this is going to be the plane y equals b. Okay, there's our plane. It's going away from us. And this is going to be a line, right? So this is going to be a line existent in the y equals, okay, hold on. Let me make it a little bit more slanted here. So this is going to be a line equal to, existent in the y equals b plane. So y equals b. That's the plane that I just drew. And this line here, the one that will continue in either direction, right? So it'll continue off along the plane. That is going to be given by this equation, x comma b comma x times sine b. Okay, so this is our other vertical trace in the y direction, or not in the y direction, but like when y is held constant. Okay, all right. So now that was it for that example. Now I'll go on to the horizontal kind of traces. Okay, so what is a horizontal trace? So if we think about it, our vertical traces were obtained by setting either our x equal to a constant or our y equal to a constant. But now we haven't set one other variable to a constant yet. So that's what our horizontal trace is going to be obtained by. So horizontal trace is we're going to set our z, also known as f of x, y, equal to a constant, and I'll call that c. Okay, so this means z tells us our height, right? How much we go up or how much we go down. So setting that equal to a constant means that we have constant height above or below the xy plane. Okay, so constant height, that's what that tells us. So this is what we're going to be doing. So let's say we have some kind, I'll just draw like a random curve, okay, or a random surface, I'm sorry. So x, y, and z. Let's say we have something like, it's like a landscape, and we have like hills on them, okay? So here are like two hills, that one's a little bit bigger, and then they continue off, and then the rest is kind of flat, okay? So something like that. Okay, so let's say we have some kind of surface that looks like that for some reason. Okay, so what would we do for a horizontal trace would be, let's pick a constant c, okay? So let's say our constant c is here. So this is c on the z axis. Okay, so we're gonna draw a plane at the height of c, of z equals c. Okay, so I'm just gonna draw that here. It's gonna be a little bit above the one that I see on the bottom there. Okay, so what we're gonna do is have this, and the z equals c plane, that's a horizontal plane. Okay, so that is horizontal, and this is going to cut through our graph. Okay, and this is what it'll look like. So here I drew the c plane, the z equals c, and this is actually going to intersect, cut through, intersect, same thing, right? That's going to intersect it here, and also let's say here, or something like that, okay? It's going to basically like cut two circles in it, in our surface here. All right, so now what do we do with this? We can't just like stare at it. I mean, it looks kind of pretty and majestic, but we can't just not do anything with it. So now that we cut this plane through our surface, through our original surface, we're going to what's called project the intersection. So these two circles that I just drew, right? These are the intersections of the plane of the z equals c plane with our surface. Okay, so what we're going to do is project this downward. So we're going to draw lines downward, basically, onto the xy plane. Okay, that's normally what we do. This is just the process. So we're going to project those down. So this exists on the xy plane, and this also exists on the xy plane. Okay, so that's down there. And now that we have these graphs down here, these two things together, the projection of our intersection, so projection of our intersection is called a level curve. Level curve. Okay, so this is basically, so I'll continue this on the next slide. So what a level curve is, so I'll write the formal definition of one. So a level curve is going to be equal to basically our f of x comma y. So that's our surface, is equal to c. So this is more or less like a colon. So this is what it means. This is when you set our surface, the equation of our surface, equal to c. And then we put it in the xy plane. Remember, we projected it down there, right? So in the xy plane. So that was the curve that exists, that we kind of just dropped down and stuck it down there. So this is the one on the xy plane. Xy, right? And those were kind of poor circles, so I'll just improve them a little bit. So anyways, now here's a little bit different concept.